All right. Looks like we're doing Algebra 2, Lecture 1011 and 1012, OAS A2A1, A2A11, the state standard. The student will use the quadratic formula to solve quadratic equations. Well, we've been solving quadratic equations for the last couple of weeks, and we've been using factoring methods, remembering that quadratic equations are equations in which the highest power of the variable is a 2. And we've used 3 factoring methods so far. And today I want to introduce the concept of the quadratic formula, and we can use that when we find a quadratic equation where the quadratic trinomial won't factor. And so we can use the quadratic formula to find the values that will make the equation true. And here's what the quadratic formula looks like. If this equals 0, this quadratic formula where a is the coefficient of x squared, b is the coefficient of x, and c is the constant, these are going to be actually numbers in a problem. A, b, and c will be numbers. If this is true, then the solution to this quadratic equation where a, b, and c are numbers, a is the coefficient of x squared, b is the coefficient of the linear term, and c is the constant, we can put these 3 values into this formula, and it will give us the values that will make this equation true. The opposite of b, whatever this is, we're going to put the opposite of it here. Plus or minus the square root of b squared minus 4ac. We plug in b squared, plug in the a value here and the c value here. All of this will be over 2a. If we can get this into our calculator, let the calculator do the walking, we'll be looking at our answers that will make the quadratic equation true. It's quadratic formula. We're going to use it to solve a few, and hopefully it will make sense. Use the quadratic formula to solve. I want to recognize that in this case up here, our variable is an x. So the variable can be anything. A, b, and c are just the coefficients. A is the coefficient of the quadratic term, b is the coefficient of the linear term, and c is the constant. A, b, and c are going to be numbers. The variable doesn't have to be an x. In this case, the variable is an n. A will be the coefficient of the quadratic term. B will be the coefficient of the linear term, that's raised to the first power, and this will be -5, let's remember that. And c will be the constant, and c will be -52. So a is 2, b is -5, c is -52. We're going to plug in a right here and here. We're going to plug in b right here and here. We're going to plug in c right here. And then hopefully we can get that into our calculator correctly. And we'll be looking at our response. So here we go. X, or in this case I guess it would be n. Our variable is an n instead of x. The variable can be anything. The values that will make this true are the opposite of b. That would be the opposite of -5 is +5. Plus or minus the square root. B squared. -5 times -5 is 25. B squared, -5 squared. -5 times -5 is 25. Minus 4 times A, which is 2, times C, which is -52. And all of this is over 2a. 2 times a is 2 times 2. 2 times 2 is 4. That's a 4. 2 times 2. I'll go ahead and call it 4. Okay, so here we go. We're going to try to do this arithmetic under the radical first. I'm going to. It is equal to 5 plus or minus the square root of, now that was -5 squared. If you were going to square that negative with a minus sign, whenever you're squaring inside, if you're going to put a minus sign inside parentheses, use this. This button right here has parentheses with a little minus sign in it. So if you're going to square -5 using parentheses, use this minus sign. Like when I this minus 52 in parentheses, I'm going to use this minus sign. This minus sign here, I'm going to use this minus sign. Why the calculators do that, we may never know. Old school calculators didn't do that. There was just one minus sign and it worked in any case. So here we go. We'll say 25 minus 4 times 2 times negative, I'm using this one, 52. And I just typed it in there just the way it looks with parentheses and everything. I'm going to hit enter. This is 441. Underneath the radical is 441. I didn't hit square root or anything. I'm just simplifying under the radical. In the bottom, we did that in our heads. 2 times 2. 2 times 2 is 4. And now we're going to simplify this a little bit. This is 5 plus or minus. Well, what is the square root of 441? Square root of 441. Let's see if I can find my square root button here. There it is. It's the second function. Square root 441. Enter. Square root of 441 is 21. So this is actually 5 plus or minus the square root, square root of 441, which is 21 over 4. Now what this means, plus or minus, I'm going to move this right up here. So I'm running out of boardroom here. I'm just going to move it. 5 plus or minus 21. Whoops. Said 21, I wrote 12. Over 4. This will be our end values. These will be our end values that will make this true. This means 5 plus 21 over 4. Or 5 minus 21 over 4. That's what plus or minus means. Those are our end values that will make this original equation true. This original equation, these will make it true. So I want to evaluate these and simplify. These are our end values, so n will equal, this is 26 over 4. That will reduce. Or, this is negative 15 minus 21 is 16 over 4. So negative 16 over 4. So my two solutions here will be reducing these by a factor of 2, dividing top and bottom by 2, n is 13 halves, or n is negative 4. And those would be our two solutions, if I haven't made a mistake. And the order of the solutions doesn't matter. This isn't an ordered pair, it's just the set whose members are the solutions of our original equation. And we found those using the quadratic formula. Let me see if I got that right, if I can find my answer sheets. Here it is right here. 13 halves and negative 4, yay! So we just plug these values in to this equation and try not to make any mistakes with our arithmetic. Let's take a look at another one. I got my answer here, so I can check it. Yeah, have a sip of coffee first. That's good. Okay, our variable's n again. So in this case, I don't see the leading coefficient, so that's an implied or an invisible 1. A is 1. B is going to be negative 7. And C is going to be negative 23. So here we go. This is the quadratic formula. Our variable is actually an n this time, so I'm going to say n equals the opposite of b. Negative b means the opposite of b, so that's positive 7 plus or minus the square root of b squared is negative 7 times negative 7, which is positive 49, minus 4 times a, which is times 1, times c, which is negative 23. All of this divided by 2 times a, which is 2 times 1, which is just 2. Excuse me. Now I'm going to try to do this with my calculator. I'm going to First thing I'm going to do is simplify underneath the radical. 7 plus or minus the square root over 2. I'm just going to figure out what this is, simplify it a little bit with my calculator. Pardon me. Be 49 minus 4 times 1, which is 4, times negative 23. Mercy. Laws has mercy. Okay, so I've got that. Now I'm going to see if 141 will simplify under the radical. We'll take the square root of the second function, square root 141, come out from under the radical and hit enter. It doesn't simplify. So these are our two answers. N is equal to 7 plus the square root of 141 over 2, or 7 minus the square root of 141 over 2. And we traditionally write it just like this in one statement. What this one statement means, 7 plus the square root of 141 over 2, 7 minus, mercy, the square root of 141 over 2. These are our two solutions if I haven't made a mistake. And we would write them like this. That would be a very common way of seeing the mercy. I'm having a hard time here. All right, let's see if those are right. Seven plus or minus the square root of 141 over 2. And they actually, in the answer key, wrote it like this. They wrote it as two separate solutions instead of one statement. That's two solutions, but that's written in one statement. All right. We have one more here, I think. Yep. Let's go ahead and see if we can do it. Oh, this one isn't set equal to 0. We've got to set it equal to 0. The other ones were already set equal to 0. That was set equal to 0, and the quadratic formula only works if the quadratic equation is set equal to 0. So this one isn't, so we're going to set it equal to 0 first. Subtracting 10 from both sides. Subtracting 10 will yield negative 16. Subtracted 10 from both sides. And now I can see that A is 4, B is 6, and C is negative 16. The quadratic formula is x, or whatever the variable is. In this case it's an A, but it doesn't matter. What matters is the opposite of B, plus or minus the square root of B squared minus 4AC. All of this divided by 2A. So here we go. Our variable is actually an A here. Don't be confused, that's the variable. This is just the coefficient. We call them A, B, and C just for the purposes of the formula. So here we go. The opposite of B is negative 6. That's positive 6, so the opposite of B is negative 6. Plus or minus the square root. B squared would be 36. B times B, 36. Minus 4 times A, which is 4. Times C, which is negative 16. All of this over 2 times A, which is 2 times 4, which is 8. Now I'm going to try to simplify under the radical without making a mistake. I'm just going to go 36 minus 4 times negative 16 and see what I get. 36 minus 4 parenthesis, 4 close parenthesis, open parenthesis, minus sign in the parentheses right down here. 16, close parentheses, enter. 250, 292. Now I'm going to go ahead and try to take the square root of 292 and see if it simplifies. I'm going to go second function, square root 292, enter. That's 2 radical 73. So this is negative 6 plus or minus. If you do this with your calculator, it'll tell you 2 radical 73. All of this divided by 8. And now, to reduce a fraction in this form, if all 3 of these, this number right here, let me do this in blue so you can see it a little more easily. If this number, and this number, and this number will all divide by the same number, that fraction will reduce. So I see that these will all divide by a factor of 2, they're all even. So that's what I'm going to do. Negative 6 divided by 2 is negative 3. Plus or minus. Negative 2 divided by 2 is 1, and 1 times radical 73 is just radical 73. Over 8 divided by 2. So I divided 6 by 2 and I got negative 3. I divided 2 by 2 and I got 1. You could put 1 here, but it won't change the value. 1 times radical 73 is radical 73, so traditionally we don't put the 1 in there. 8 divided by 2 is 4. 73 won't come out from under the radical. You could try it, it won't. So we would leave our answers just like this. And if the book is being consistent with how they're writing their answers, they would write it as 2. They say negative 3 plus radical 73 over 4 is one of the answers, and negative 3 minus radical 73 over 4 is the other answer. The other solution of the quadratic equation. Negative 3 plus radical 73 over 4. Negative 3 minus radical 73 over 4. That's what plus or minus means. So there we are. That's using the quadratic formula. With a little practice you can do this. If you need any help getting the information into the calculators, let me know. You can do this.